Okay, this is chapter 5.4, solving radical equations and inequalities. So the essential question is, how can you solve a radical equation? So what you will learn is how to solve equations containing radicals and rational exponents, and how to solve radical inequalities. Okay, so without any further ado, let's take a look at what this chapter section has to offer. Okay, solving equations. Equations with radicals that have variables in their radicands are called radical equations. Okay, let me rephrase that, or let me restate that. Equations with radicals that have variables in their radicand. Okay, a variable under the radical. Radicand is what is in the radical. They're called radical equations. An example of a radical equation is 2 square root x plus 1 equals 4. What makes this a radical equation is this variable being under the square root symbol. Core concept, solving radical equations. To solve a radical equation, you follow these 3 steps. 1, isolate the radical on one side of the equation if necessary. 2, raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. And then step 3, solve the resulting equation using techniques you learned in previous chapters to check your solution. And then you finally check your solutions. Okay, so let's take a look at this. So I am going to move on to the next chapter, or the next example, but it's going to come back to these 3. And I'll probably bring this over to every example so we follow these 3 new steps. Okay, so here's example 1. They gave us 2 problems to solve. And there's an x under this radical. There's an x under this radical. Notice the index is 2 here and 3 here. When there's no number, it's a 2. Okay, so step 1, isolate the radical on one side of the equation if necessary. So here is a. First thing I'm going to do is just rewrite this. 2 times the square root of x plus 1 equals 4. Well, this is not inside the radical, so I need to get rid of that. Okay, so I'm going to divide. That means 2 times the square root of x plus 1. So the inverse is division. I divide both sides by 2. 2 divided by 2 is 1. I get the square root of x plus 1 equals 4 divided by 2, which is 2. Okay, so there's step 1. I isolated the radical on one side of the equation. Then it says raise each side of the equation to the same exponent to eliminate the radical. Well, if this is a square root, because there's no number here, it's a 2, then I'm going to square the square root symbol. And what you do to one side, you must do to the other. So I'm going to square 2. When I square both sides, the radicals cancel, and I get x plus 1 equals 2 squared, which is 4. Okay, that's step 2. All right, so step 3, so step 2 is done. Step 3 says to solve the resulting equation using techniques you learned in previous chapters and check your solution. So I have x plus 1 equals 4. So obviously to get rid of that 1, I subtract 1 from both sides and I get x equals 3. It says check your solution. So I'm going to put it back into the original equation. So I'm going to put 2 square root of 3 instead of the x plus 1 has to equal 4. Okay, order of operations says to do what's inside the radical first, and that's 4. And then do the operation here, take the square root of 4 first, which would be square root of 4 is 2, so that's 2 times 2. And this has to come out to equal 4, and obviously 2 times 2 is 4, and I have checked my solution. So that is how you solve a radical equation. So now let's try it one more time with B. So the first thing I do is rewrite the problem. So it's a 2x minus 9. And don't forget that index is 3 this time. Minus 1 is outside the radical, and that equals 2. The first step is to isolate the radical. In other words, get this radical right here by itself. So I need to add 1 to get rid of that 1 that's not in the radical. And when I do that, I get the cubed root of 2x minus 9. Negative 1 plus 1 is 0, equals 2 plus 1, which is 3. In order to get rid of the radical, you have to take the power of the index to cancel it. So I'm going to cube both sides. So the cubed root cubed cancels, and I'm left with 2x minus 9 on the left. 3 cubed is 3 times 3, which is 9 times 3, which is 27. So 3 to the third power is 27. So then I want to so that's step 1 and 2. Step 3 says to solve the resulting equation using techniques you learned in previous chapters and in Algebra 1. So to get that x variable by itself, we first add 9 to both sides. These cancel and I get 2x equals 27 plus 9 is 36. Divide both sides by 2, and these cancel, or it's 1, and x equals 36 divided by 2, which is 18. Now I check. I put the cubed root of 2 times 18 minus 9 minus 1 has to equal 2. So do what's under the radical first, and multiplication comes first. So it's 36. 36 minus 9 minus 1 equals 2. So the cube root of 36 minus 9 is 27 minus 1 equals 2. Okay, let me just drag this down a little bit, and I'm going to add 1 to both sides. Actually, no, I'm not. I'm trying to see if this equals 2. The cube root of 27 is 3. Minus 1 equals 2. 3 minus 1 is 2. 2 equals 2. It checks. Okay, so that is how you solve radical equations. So with this example, you should be able to do problems 3 and 4 on your exercise. Okay, example 2, solving a real-life problem. In a hurricane, the mean sustained wind velocity in meters per second can be modeled by V of P equals 6.3 times the square root of 1013 minus P, where P is the air pressure in millibars at the center of the hurricane. Okay, this is very physicsy. Okay, we're getting prepared for physics with this. Remember what mean is. The mean sustained wind velocity. Mean is average. The average sustained wind velocity. And here's the equation. Velocity in terms of, so V of P means when P, air pressure, is a certain amount, we can find out the velocity with a given pressure. Okay, so it says estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. So here they're giving us velocity and asking us to find pressure. So it can work both ways when you have an equation. So let's take a look. The first thing I'm going to do is rewrite that equation. V of P equals 6.3 times the square root of 1013 minus P. Okay, so there's our equation. I just copied it from up here. But now they're saying estimate the air pressure. So we're trying to find P. When the mean sustained wind velocity V in meters per second, P, is 54.5. So the first thing I'm going to do is substitute this value in for V of P. So 54.5 equals 6.3 square root 1013 minus P. Okay, so remember our steps. I'll go back one. One, isolate the radical. The radical is not alone. It's got a 6.3 being multiplied outside. So I'm going to isolate the radical by dividing both sides by 6.3. Okay, these will cancel, and I'm going to get the square root of 1013 minus P. And if I get my trusty calculator out and I take 54.5 divided by 6.3, I get 8.650793651, blah, blah, blah. We are going to approximate it to 8.65. So let me change this. Hello, eraser. Change this to an approximate symbol, and it was 8.65. Okay, so now we have the radical isolated. So we take step 2. Let me go back one. Raise each side of the equation to the same exponent. Okay, so it's a square because there's a 2, no 2 here. If there's nothing there, it's a 2. So I'm going to square it. What you do to one side, you do to the other. Okay, and that is going to give me another approximation, and this is going to be 1013 minus p, because the radical cancels. But what is 8.65 squared? Here's where I like to be more accurate than maybe the book might be. They might round and then square. It is more accurate to just simply square the number before rounding it. And I'm going to get 74.836, which is 74.84. I'm going to go out 2 decimal places. So it's 74.84. Okay, in order to get p by itself, I need to now get rid of this 1013 by subtracting it. And that is going to give me a negative p on this side. And if I take 74.84 minus 1013, I get negative 938.16. And since they're both negatives, if you multiply this whole thing by -1, you're going to get 938.16 is approximately p. Okay, so I just multiplied everything by -1 to get the opposite. And the air pressure at the center of the hurricane is about 938 millibars. And that is how you use this in a real world scenario using kind of physics, if you will. We're starting to look at the sciences where math is used in science a lot in physics. Okay, so now you should be able to do problem number 13. Okay, so now raising each side of an equation to the same exponent may introduce solutions that are not solutions of the original equation. Let me highlight that. Not solutions. I don't know what is wrong with this program. I click on that and I went, bleh. All right, not solutions of the original equation. These solutions are called extraneous solutions. When you use this procedure, you should always check each apparent solution in the original equation. Okay, in the original equation. All right, so let's take a look. Solve this. The radical is all by itself. The only difference between this equation and what we've been working with is there is a variable on both sides this time. No big deal. We have a radical all by itself. So therefore, step 1 right here, isolating the radical, is not necessary. That's what they mean by if necessary. So the next thing we're going to do is raise each side of the equation to that power. So if I go back to this is a square root. So I'm going to square both sides. Notice what I'm doing here. I'm putting that in parentheses. Do not just square the 1. Okie dokie. X plus 1 squared is not x squared plus 1. You can't forget your middle terms. X plus 1 squared means x plus 1 times itself. And if you write it like this in FOIL, you get x squared plus x plus 1, which is x squared plus 2x plus 1. Okay, so that being said, that was just a quick review. That's why I went quickly. You should all know that. And so x squared plus 2x plus 1 is this, equals 7x plus 15. When I squared the radical, it canceled. So there we have it. Notice we have a squared value, x squared. This is a quadratic. We want to set it equal to 0 to solve it. So I'm going to subtract 7x and I'm going to subtract 15. You can do it all at once. Minus 7x minus 15 from both sides of the equation. X squared does not change. 2 minus 7 is negative 5x. 1 minus 15 is negative 14. These are 0 and 0 and 0. Okay, so we got x squared plus minus 5x minus 14. So we then check, first look for a GCF, 1, 5, 14. Obviously there isn't any. So the next thing we do is try to find factors of C, 14, that add up to B, 5. So if I do this again over here, 14 is 1 times 14, and I'm getting a negative, and both signs are negative, or both the signs are opposite because this is negative, and the larger one is negative. So I do that. Okay, let me say that again. C is negative, so it's a positive times a negative to get a negative at the end. And when the middle term is negative, it means the bigger of the two is negative, because when you add 1 and negative 14, you get negative 13. Okay. And so other factors of 14 are 2 times negative 7, and that's actually negative 14. Okay, so there it is. 2 plus a negative 7 is negative 5. So it's x plus 2, x minus 7. So using the zero product property, set each factor equal to 0. X plus 2 equals 0, or x minus a 7 equals 0. Solve for x by subtracting 2 from both sides, and I get negative 2. And solve this one by adding 7 to both sides, and I get 7. So x equals 2, or x equals 7. Don't forget to check for extraneous solutions in the original. So now I'm going to write over here, using x as negative 2. It's going to be negative 2 plus 1. And let me erase this here because that is not in our original. Negative 2, and I wanted to color code this, okay? Negative 2 plus 1 equals the square root of 7 times that x, which is negative 2, plus 15. Okay, so I'm just trying to show this really clearly. Negative 2 plus 1 is negative 1 equals the square root of negative 14 plus 15. Negative 1, oh, there's a problem right there, equals the square root of 1. Negative 1 equals 1, and no, it does not. So this is an extraneous solution. Okay, I did not do that, by the way. My computer just whacked out. Anyway, x equals negative 2 is the extraneous solution. Now I need to check the other one. So it's x plus 1 equals the square root of 7 times x plus 15. Okay, over here, I'm going to get back to that in a minute. 7 plus 1 is 8. And 7 times 7 is 49 plus 15. And 8 equals the square root of 49 plus 15 is 64. And the square root of 64 is 8. So that one checks. So x plus 7 is our solution. Okay, so when we're checking these, as soon as you get a negative number on one side that's equal to a radical that's isolated, you are done. That is extraneous. So I could have stopped right here because a radical cannot equal a negative. That would be imaginary. Okay, that can't happen. All right, so the answer is x equals 7. Okay, example 4 is solving an equation with 2 radicals. All right, so we're just adding a little bit to what we've already done. We can't isolate. First thing I want to say is if you try to do step 1, let me go back to here. Step 1 is isolate the radical to one side of the equation if necessary, if possible, actually. Because here it's not. If I subtract 1, don't do this, just watch. If I subtract 1 from this side to isolate this radical, I get x plus 2 equals the square root of 3 minus x minus 1. So now this radical is not isolated. So I can add 1 to both sides to isolate this, but then we're back to where we started. So don't do that. You don't ever want to do that. It's not possible. So what we're going to do is we're going to square both sides. So I'm going to rewrite this with parentheses. And the left side is x plus 2 square root of x plus 2 plus 1, close the parentheses, equals the square root of 3 minus x. I'm going to square both sides. All right, so what does that mean? Well, that means that you have the square root of x plus 2 plus 1 times itself. And I'm going to write it like this so we don't make a mistake while we FOIL. Or distribute, if you will. And this one's easy. That's just going to become 3 minus x because the radical and the squared cancel, leaving us with the radicand. All right, so now let's take a look at this. We have a radical times a radical, and when the radicand is the same, you just get that number, because if I have the square root of 3 and I multiply it by the square root of 3, That is the square root of 3 times 3, which is the square root of 9, which is 3. So when the radicands are equal and you multiply them by the same radical, then the radicals just cancel. Okay? I just wanted to clarify that first. So that means that if I take the square root of x plus 2 times the square root of x plus 2, I get x plus 2. Outer is this times 1, which is the square root of x plus 2. And inner is 1 times the square root of x plus 2, which is the square root of x plus 2. And then the last is 1 times 1, which is 1. And then I put equals 3 minus x. Okay, let me just move this a little bit. I like stuff lined up. So my equal signs are in line. Let's just do this. Only I could do that on paper. All right, so there it is, equal sign all lined up. The right side's just coming for a ride because the work's all being done on the left. I have a 2 and I have a 1. I will rewrite that as 3. I have an x that's not in a radical, so I'll put that there. And square root of x plus 2 plus another square root of x plus 2 is 2 square root x plus 2. So these two got added to give us 2 times that. Plus x is right there, and 2 plus 1 is 3. I just simplified the left, and now I'm going to subtract 3 from both sides and subtract x because I'm isolating my radical. So minus 3 minus x, and that is going to give me 2 square root x plus 2. And this x minus x is 0. 3 minus 3 is 0 equals 3 minus 3 is 0. Negative x minus negative x is negative 2x. Now I have 2 times a radical. Remember, I'm trying to isolate that radical. Divide both sides by 2. And these cancel. And I get the square root of x plus 2 equals negative 2 divided by 2 is negative 1x. Okay. Now my radical's isolated. I square both sides. I'm going to put parentheses around this. Be careful when you do that. The square root of x plus 2 squared is x plus 2. And a negative x squared is x squared. A negative times a negative is positive. Think of that as negative x times negative x. And a negative times a negative is positive, and x times x is x squared. Okie dokie. So that's x squared. So now that we have a radic or a quadratic, we need to set it equal to 0 to solve it. So I'm going to subtract x and subtract 2, subtract x, subtract 2, and this becomes 0, x squared minus x minus 2. Okay, so now we have a radical. Or yeah, I keep saying radical. Now we have a quadratic, and 1, 1, 2, there's no greatest common factor. So I'm going to try to factor it this way. I have factors of negative 2, and I want them to add up to a negative 1. So 1 times negative 2 is the only way I can get a negative in the middle, and a positive times negative is a negative outside. And there are my two values that give me negative 2. When I add, I get negative 1. So it's x plus 1, x minus 2 equals 0. Now we do the 0 product property, setting each equal to 0. So we have x plus 1 equals 0, or x minus 2 equals 0. Subtract 1, x equals negative 1, or add 2, x equals 2. All right, so now we want to plug that into the original and check. So if I go back up to the original, it is the square root of x plus 2 plus 1 equals the square root of 3 minus x. All right, so I just brought this down twice because we're going to substitute in different values. And let's take a look. So we have the square root of x, which is negative 1, plus 2, plus 1. And that has to equal the square root of 3 minus negative 1. Okay, so negative 1 plus 2 is 1. And 3 minus a negative 1 is 3 plus 1, which is 4. So the square root of 1 is 1 plus 1 equals the square root of 4, which is 2. 2 equals 2. That checks x minus 1 is a solution. Then we check for 2. Okay, so we're going to put the square root of, and now x is 2 plus 2. Got crazy again with my radical. And plus 1 equals the square root of 3 minus, and x is 2. All right, so the square root of 2 plus 2 is the square root of 4 plus 1 equals the square root of 1. 2 plus 1 equals the square root of 1. Actually, I know the square root of 1 is 1, so I'm just going to put 1, and 3 equals 1. No, it doesn't. X is not a solution when it's 2. I should say 2 is not a solution for x. X is negative 1 is the only solution to this problem. Okay, x equals 2 is extraneous. So now that I've done these examples 3 and 4, you should be able to do problem numbers 15 and 16. Okay, example 5 puts a little twist on it, but it's really simple. Compared to using radicals, it's pretty much the same concept. So it says solving an equation with rational exponents. So remember this to the 3/4. 2x, I write 2, 4. Let me try that again. 2x to the 3/4 means we're taking 2x, putting a radical over it. The bottom number is your index, your top number is your power. This is equivalent to that. Okay, I could solve it this way, but it's easier just to leave it a rational number. So let me get rid of this. And I'm going to rewrite the problem. 2x to the 3/4 plus 2 equals 10. So we want to get our rational expression by itself. In other words, isolate it, just like we did the radical. Let's get rid of this 2 first by subtracting. And that will leave us with 2x to the 3/4 equals 8. Okay, that's step 1. 2x to the 3/4 equals 8. Well, I want my power to be 1. So let me just make some room here. The 4 is connected. Okay, so I'll just erase that and rewrite it where it belongs. I'm going to leave a little space there because I'm going to put a bracket around this. And power of powers rule says to multiply. In other words, if I have x to the 3 squared, that means we take x to the 3 times 2, which is x to the 6. Okay, same thing here. But in this case, I want a 1. So 3/4 times what is 1? Okay, well, anything times its multiplicative or its reciprocal, multiplicative inverse is 1. Okay, so what's the inverse of 3/4? It is 4/3. So if I multiply, if I multiply 3/4 times 4/3, I get 12/12 or 1. And what you do to one side, you do to the other. So this 3/4 and 4/3 is going to cancel, leaving me with just simply 2x equals. Okay, so what in the world is 8 to the 4/3? Well, you could just put it in your calculator. I'll show you how to do that. On clear, 8 to the power of 4 divided by 3, enter, and it's 16. Okay, so that's 16. Well, let me explain that. 8 to the 4/3 is the cubed root of 8 to the 4th, which is 8 times 8 is 64. So if I did this, it's 8 to the 4th is 4,096. And then if I take the cube root, clear math, if I take the cube root of 4096, I should get 16. And there it is. Okay, so it's just as easy to use a calculator, but if you don't have a calculator, then that's how you do that. Divide both sides by 2, the 2's cancel, I get x equals 8. Okay, so what have I not done yet? Oh, check, check, 1, 2. All right, so I'm going to put a 2 here. I'm doing the original equation. Substitute in my 8 for my x to the 3/4 plus 2 equals 10. So I wanted to make sure that left side equals 10. So this is 16 to the 3/4 plus 2 equals 10. 16 to the 3/4 we already did. 16 to the power of 3 divided by 4 is 8. Plus 2 equals 10. 8 plus 2 is 10. 10 equals 10. It checks. 8 is our solution. Okay, so that's how we solve equations with a rational exponent. Okay, example 6. This is a bit lengthy, this chapter section, but anyway, x plus 30 to the 1/2, I'm going to leave some space there, equals x. First thing I'm going to do is put a bracket around here. And I want 1, so I want the reciprocal, 2 over 1. What you do to one side, 2 over 1 is just simply 2, so I'm going to put a 2 here. 1/2 times 2 over 1 is 2 over 2, which is 1. And that leaves me with x plus 30 equals x squared. See, that wasn't so bad. Now we're back to a simple quadratic. Get everything on one side, set it equal to 0, and factor. So subtract x, subtract 30, subtract x, subtract 30. X minus x is 0. 30 minus 30 is 0, equals x squared minus x minus 30. I have a negative power or constant. So I want factors of negative 30 that add up to a negative. So I want a positive times a negative, 1 times negative 30. And the bigger number's got to be negative for the middle term to be negative. So 1 times 30, 2 times a negative 15, and 3 times negative 10, and 5 times negative 6. Those are all the factors of 30 that would give us a negative in the middle term. And I want negative 1. So obviously it's 5 and negative 6. So now I have 0 equals x plus 5 times x minus 6. 0 product property says to set each factor equal to 0. And x minus 6 equals 0. And solve for x. X equals negative 5 or x equals 6. Okay, now that we've done that, we're going to check our solutions. Okay, so I'm going to write it in the original. X, negative 5, plus 30 to the 1/2 equals x. Okay, simplify. Negative 5 plus 30 is 25. To the 1/2 equals negative 5. And that means square root, by the way. Remember, the denominator is your rat index and your numerator is your power. So it looks like that. So it's obviously the square root of 25. Square root of 25 is 5. 5 does not equal negative 5. I can't get a negative when I take a square root unless it's imaginary. Okay, so 5 does not equal negative 5. Okay, so now let's try it one more time. I'll switch to green this time. So I have parentheses. My x is negative 5. No, it's not, it's 6. Just kidding. Okay, x is 6 this time. Plus 30 to the 1/2 equals x, which is 6. All right. 30 plus 6 is 36 to the 1/2 equals 6. The square root of 36 is 6. 6 equals 6. That checks. My only solution is x equals 6. X minus 5 is extraneous. So that is not a solution. Okay, so now that I've done examples 5 and 6, you should be able to do exercises 27, 28, and 32. Okay, example 7, solving a radical inequality. Very similar to doing an equation. We just have to focus on the radicand here, and I'll explain that as I go. Let me highlight the radicand right there. That thing cannot be negative, or else I get an imaginary number. So let's keep that in mind. So first thing I'm going to do to solve this is just rewrite it. 3 times the square root of x minus 1 is less than or equal to 12. So with inequalities, it's the same as equations. Isolate the radical by dividing both sides by 3. That will leave me with the radical all by itself, less than or equal to 12 divided by 3, which is 4. Now we square both sides, and I get x minus 1 is less than or equal to 16. Add 1 to both sides. So actually, this is really simple, very basic procedure, and we get x is less than or equal to 17. But remember, we have to focus on this. Remember that that cannot be 0. So x minus 1 has to be greater than or equal to 0. Don't forget this step, because if I say x is less than 17 and I go beyond 0 to -5, I put -5 in here, I get square root of -6. Or say I put the square root, or say I went to -8. -8 minus 1 is -9. The square root of -9 is 3i. 9i is less than or equal to 12. It's imaginary. How can you compare it to a real number? You can't. So that's why we take and set the radical equal to 0 and then say it has to be greater at the same time. Now solve for x, and x is greater than or equal to 1. Okay, so now I have a compound inequality. So x is less than or equal to 17, but it's greater than or equal to 1. So this is my solution. So if I were to graph that, let me do it with Desmos. 3x minus 1. So let me enter it into Desmos. Let me bring up Desmos here. Okay, so I opened up Desmos. It's back here. So I want to graph 3 times the square root of x minus 1 is less than or equal to 12. So 3 times the square root of x minus 1, and I'm going to say y equals 12. Okay. Where is it? Right there. So let me just zoom out so we can see this. So this is the function 3 times the square root of x minus 1. It's that red function here. And I want to know when it is less than or equal to 12. Well, it equals 12 right here at 17, 12. So now if I write x equals 17, then all this value here is less than 12 until I get to there. Then it's equal to 12, but then it's greater than 12. So I want to be less than 17. And then what is my value down here? It is 1, 0. So now I'm going to put x equals 1. Now, the reason I'm doing this is I want to show you about domain and range. So here's our function, and it had to be less than or equal to 12. So it had to be below the line y equals 12, and that is this here. Okay? But I can't go negative. I cannot have a negative because then I am dealing with imaginary values. So my domain is between 1 and 17. And that's how the graph is explained with our domain values, x being between 1 and 17 inclusive. Okay, hopefully that makes sense to you. And now you should be able to do problem numbers 37 and 38. Okay, this brings us to the end of chapter 5.4. I didn't give a whole lot of problems to do in this chapter, but here they are. So please give these a shot, and thanks for watching and have a great day.